Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, find constants a, b and c such that the function f at x equals ax cubed plus bx squared plus c will have a local extremum at 2, 11 and a point of inflection at 1, 5. Now, local extremum means either local minimum or local maximum. So this means that the point 211 lies on the function because this point represents the turning point on this function either in the form of a peak or a valley. So that means we can sub in the function value as 11 and x as 2 in this given function equation. So we get 11 equals a times 2 cubed plus b times 2 squared plus c. Now we can simplify this equation. So 11 equals, so 2 to the power 3 is 8. So we get 8a plus, now 2 squared is 4 plus 4b plus c. So this is the first equation we get in terms of a, b and c. Now we are also given that the point of inflection for this function is 1, 5. So that means this point 1, 5 also lies on the function. So we can sub in the function value as 5 and x as 1. So we get 5 equals a times 1 cubed plus b times 1 squared plus c. Now we can simplify this equation. So 1 cube is equal to 1 and a times 1 will just be a. 1 square is 1 and 1 times b will just be b plus c. So this is the second equation we get with a, b and c. Now we can simplify these two equations we got with a, b and c to get rid of the constant c. So we can rewrite these two equations. Now we can use the elimination method. So if we subtract these two equations, the c terms will cancel each other out. So 11 minus 5 is equal to 6, 8a minus a is 7a, and 4b minus b is equal to 3b. So we get this equation just in terms of a and b. Now we're also given that 1, 5 is a point of inflection. So we know at point of inflection, the second derivative is equal to 0. So we now have to find the derivative of the given function f at x. So we'll first find the first derivative and then the second derivative. So prime of f at x equals, so for the first term, a is the coefficient, it's a constant, so it will stay as it is. And we can find the derivative of x cubed using the power rule. So as per the power rule, we'll move the exponent 3 to the front and subtract 1 from 3 in the exponent. Plus, now in the second term, b is the coefficient and it's a constant, so it will stay as it is. And the derivative of x squared is 2x. Now c is a constant, so its derivative is equal to 0. So now we can simplify this expression. So prime of f at x equals, So in the first term, we do 3 times a, which is 3a, x squared, and then plus 2b x. So the 0 goes away. Now we can find the derivative of prime of f at x to get the second derivative of f at x. So double prime of f at x equals, so in the first term 3a is a constant and it's the coefficient, so it will stay as it is, and the derivative of x squared is 2x. Now in the second term 2b is the coefficient and it's a constant, so it will stay as it is, and the derivative of x is 1. Now we can simplify this expression. So 3 times 2 is 6, so we get 6ax plus 2b. Now since the inflection point is at 1, 5, so we can sub in the second derivative as equal to 0 for x equals 1. So we get 0 equals 6a times 1 plus 2b. Now we can simplify this equation. 0 equals 2b. Now we can isolate b in this equation. So we can move 2b to the left side. So we can subtract 2b from both sides. So the 2b's on the right side will get cancelled out. So we get negative 2b equals 6a. And now we can divide both sides by negative 2. So negative 2 on the left side get cancelled out. So we get b equals, so 6 divided by negative 2 is negative 3. So we get negative 3a. Now we can do the substitution for b in the other equation we got. 6 equals 7a plus 3b. So we can do it on the side here. So we got the equation 6 equals 7a plus 3b. Now we can do the substitution for b plus 3 times negative 3a. So now this equation has only a, so we can solve this equation to find the value of a. So first we can do 3 times negative 3, which is equal to negative 9. Now we can combine the a terms. So 7 minus 9 is negative 2. Now we can divide both sides by negative 2. So negative 2 on the right side get cancelled out, and 6 divided by negative 2 is negative 3. So a is equal to negative 3. So this is the final answer for the value of a. Now we can find the value of b by subbing in a as negative 3. So we can use this equation. So b equals negative 3 and the a value is negative 3. So b is equal to positive 9. So this is the final answer for the value of b. Now we can find the value of c, and for that we can use this equation here that we got by subbing in the point 1, 5 in the given function equation. So that equation we got was 5 equals a plus b plus c. Now we can sub in the value of a and b. So 5 equals negative 3 plus 9 plus c. Now we can combine negative 3 and plus 9, which is equal to 6. And now we can subtract 6 from both sides to isolate c. So on the right side, the 6's will get cancelled out. So 5 minus 6 is equal to negative 1. So this is the final answer for the value of c. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.